Good day and welcome to Math 111H Calculus 1 Honors, The Joys of X. Today we're going to discuss indeterminate forms and L'Hopital's rule. The question we want to understand is how can we analyze limits that as x go to a become 0 over 0 or infinity over infinity. Such expressions can really become anything, and we want to understand how to analyze them. We've already learned some tricks for analyzing such limits, such as factoring and multiplying by conjugates, or possibly doing some other tricks. Now we'll learn a new way. Today's key theorem, L'Hopital's rule, is the following. Suppose f of x and g of x are differentiable functions, and that the derivative of g prime of x, is not 0 near x equal a, except possibly at x equal a. And suppose that the limit as x goes to a of f of x is f of a, and that's 0, and the limit as x goes to a of g of x is g of a, and that's 0. So we have f of x is going to 0, g of x is going to 0, and we want to consider the limit as x goes to a of f of x over g of x. Well, that's going to be 0 over 0. But L'Hopital's rule says that then we can just take the derivative of the numerator and the derivative of the denominator, and the limit as x goes to a of f over g is going to equal the limit as x goes to a of f prime over g prime. Let's just take a look for a moment as to why that works. If we consider the limit as x goes to a of f of x over g of x, where f of x and g of x are going to 0, well, we can just subtract f of a and g of a because that's just 0. Now we can divide by x minus a and multiply by x minus a. But this first part of the limit as x goes to a of f of x minus a over x minus a, well, that's just the definition of the derivative. That's f prime of x. The second piece, the x minus a over g of x minus g of a, well, that's the reciprocal of g prime of x. So what we get is that the limit as x goes to a of f of x over g of x, when f of x is going to 0 and g of x is going to 0, is simply the limit as x goes to a of f prime over g prime. The other result that's also called L'Hopital's rule is that if f of x and g of x are differentiable and g prime of x is not 0 near x equal a, except possibly at x equal a, and suppose f of x is going to plus or minus infinity and g of x is going to plus or minus infinity, we can also use L'Hopital's rule in that case. Then the limit as x goes to a of f of x over g of x, which would be infinity over infinity, well, that's the limit as x goes to a of f prime of x over g prime of x. Let's just consider a few examples. We made a great effort to understand the limit as x goes to 0 of sine x over x earlier in the course. Well, now we can use L'Hopital's rule. As x goes to 0, sine of 0 is 0. X going to 0 means x equals 0. X is going to 0. And so we can use L'Hopital's rule. We take the derivative of sine x. We get cosine x. Derivative of x is equal to 1. And as x goes to 0, that's cosine 0, which is 1 over 1. So the limit is 1, and we quite easily get to the limit. We can consider the limit as x goes to infinity of e to the x over x squared. If we just plugged in infinity, we'd get infinity over infinity. We take the derivative of the numerator and derivative of the denominator, e to the x over 2x. We still get infinity over infinity. So we can use L'Hopital's rule again until we don't get 0 over 0 or infinity over infinity. Here we get the limit as x goes to 0 of e to the x over 2, which becomes infinity over 2 or infinite. Finally, let's consider the following example. The limit as x goes to 0 from the plus side of x times log x. Well, as x goes to 0, the first piece becomes 0. Log of 0 is minus infinity, so we really get 0 times an infinity, and that's also a problem. What we do in many of those kind of cases is we bring the x to the denominator. We write this as the limit as x goes to 0 from the plus side of log x divided by 1 over x, right? Because the 1 over x in the denominator would be the same as an x in the numerator. Now as x goes to 0, we get minus infinity on top and infinity on the bottom, an infinity over infinity kind of case. So that's equal to, we take the derivative of the numerator and derivative of the denominator. Derivative of log x is 1 over x. Derivative of 1 over x is minus 1 over x squared. We simplify, getting x over minus 1, and as x goes to 0, that quantity becomes 0. So the limit as x goes to 0 from the plus side of x times log x is equal to 0. We can also apply L'Hopital's rule, if we're a little tricky and strategic, to other indeterminate forms. Suppose we need to compute the limit as x goes to 0 of f of x to the g of x, and that when we plug x equal a in, we end up with 0 to the 0, infinity to the 0, or 1 to the infinity. These three forms can be anything. We cannot evaluate them without doing something more strategic. What we do in this case is we let y equal f of x to the g of x, and we consider log of y. That's equal to g of x times the log of f of x. Then we can compute the limit as x goes to a of the log of y, and when we find what the log of y is going to, we can exponentiate to find the limit as x goes to a of y, and that's what we wanted to find in the first place. Okay, so let's consider an example. The limit as x goes to infinity of 1 plus 1 over x to the x. Well, 1 over x as x goes to infinity becomes 0. So you get something like 1 plus a very small number to a very large number. So that's going to 1 to the infinity, one of our indeterminate forms. So we let y equal 1 plus 1 over x to the x. Take the log of both sides. We get log of y is x times the log of 1 plus 1 over x. We use the method or trick that we just used a moment ago, considering the limit as x goes to infinity of the log of y is equal to the limit as x goes to infinity of log of 1 plus 1 over x divided by 1 over x, right? We bring that x to the denominator. We can notice that this gives us the natural log of 1 as x goes to infinity, which is 0, divided by 1 over x, which also goes to 0. So we're getting a 0 over 0. We apply L'Hopital's rule. The derivative of the numerator is 1 over 1 plus 1 over x times the derivative of 1 over x, which is minus 1 over x squared. The derivative of the denominator is minus 1 over x squared. These minus 1 over x squareds cancel out, and we plug in x goes to infinity, giving us 1 over 1 plus 0, or 1 over 1. And so that what we find is that the log of y is going to 1. And since the log of y is going to 1, y is going to e to the 1, or e. Let's take a moment for math culture. A professor at a certain university had a strict policy that the hourly examinations were done at the bell, and anyone who kept writing on their exam after the bell would get a 0 on the exam. Well, one student kept writing on his exam for a while after the bell and then confidently strode up to turn it in. The professor looked at the student and said, "Don't bother to hand that paper in. You get a 0 for continuing after the bell." The student looked at the professor and said, "Professor, do you know who I am?" The professor replied, "No, and I don't care if your dad is president of the United States. You get a 0 on the exam." The student, with an enraged look on his face, shouted, "Do you mean to say that you have absolutely no idea who I am?" The professor responded, "No, I have no idea who you are." With that, the student said, "Good," and he plunged his exam into the middle of the stack of the other students' exams and did a hasty retreat from the room. Thank you for joining us today. Have a great day, and may the power of math be with you.